Hi, good morning, gentlemen. I hope you all had a great Easter. Spend some time with your family. I hope you guys are staying safe during these rough times. I'm thinking about you and I'm praying for you. Uh, but let's get back to it. I know it's been a while since we've written some notes, but we got to get back to it. So the past couple of weeks, I taught you how to graph sine graphs, sinusoidal graphs, and cosine graphs. All right. So today we're gonna be graphing just the parent function, just the main one, the tangent function. Okay, everything is gonna compare to. Tomorrow we're gonna be looking into how it can change with the amplitude and the shifts and stuff like that. But today I'm just gonna show you what a tan function looks like. All right, just a regular tan function, tan of x. All right. So if you recall, right, you recall that tangent, so tan of theta, is just equal to sine over cosine. So sine of theta over cosine of theta. Alright, so one thing you need to know, right? We've learned this, we saw this throughout the year, is that the tangent will be 0 whenever its numerator, in this case the sine, is equal to 0 to 0. So when does this happen? When does sine equal 0? So sine equals 0 at what? 0. So sine equals, let's do this. Sine equals 0 at 0, pi, 2 pi, 3 pi, so on and so forth. But it also is 0 at negative, so it's equal to negative pi, negative 2 pi, negative 3 pi, and etc. Right? So you see a pattern that is just by pi's. Alright? Now, the tangent, right? We know that it's going to be 0 at these points. But now we got to figure out, we're going to have a little interval. Alright? So we're just going to look at the interval. So the interval from negative pi to 2 pi. Alright? Now, there's going to be how many zeros? So you have at negative pi, so sine's going to be, it's going to have 4. Negative pi and 0, pi and 2 pi. There's going to be 4 zeros. Alright? Now, the tangent will be undefined. Tangent will be undefined. Right? Oh, let me put that in red so it can make more sense. Undefined, right? When is a fraction undefined, right? If we think back, I said that a fraction is undefined when the denominator is equal to 0. So this, in this case, is when cosine is equal to 0. So will be undefined when cosine is equal to 0. So also with that being said, if you remember, whenever, wow, that was terrible. Whenever you have a undefined value while graphing, you have asymptotes. In this case, you will have vertical asymptotes So why will I have vertical asymptotes? I'll tell you right now. Where cosine equals 0, pi, negative pi over 2, pi over 2, 3. So the reason you're going to have vertical asymptotes, right? If we think about it, if I told you before cosine is x, sine is y, right? So when you look at your x-axis, right, and it's not going to touch that value, you have to draw a little vertical asymptote there. The vertical asymptotes go with your x, and the horizontal asymptotes go with your y. Alright, so in this case, since cosine is in the denominator, but it's the x, there's going to be vertical asymptotes at that place. Alright, also remember a graph will never touch an asymptote. It will get close to it, but never touch it. Now, we have many different points that we need to worry about, right? We already have that we have zeros at negative pi, 0, pi, and 2 pi, and we have asymptotes from we have asymptotes at negative pi over 2, pi over 2, and 3 pi over 2, right? Because that's when cosine is equal to 0. Now we have to put those points together, and we have different intervals. So we're gonna have 1, 2, 3, 4, 5. We have 6 different intervals. Okay, so let's pay close attention. So, like I said, tan equals sine over cosine, right? So let me rewrite it. So tan is equal to sine over cos. All right, and this is how we're gonna find direction of the graph. Okay, so the first one that we need to know is from negative pi to negative pi over 2. Right? We have that sine is negative, cosine is negative. So if sine is negative and cosine is negative, negative over negative, that means that the tangent is positive, right? So then the next one, I have negative pi over 2 to 0. So as you guys can see, I am going in intervals of pi over 2. So from negative pi over 2 to 0, sine is still negative, cosine is positive. So if I do negative over positive, that just means that the tangent is going to be negative. All right, next one, we have 0 to pi over 2. We have that sine is positive, cosine is positive, so the tangent is positive. Now, this is the direction of that graph at that interval. That means how the tangent is going to be looking. Okay, so if you're not understanding what I'm doing, before I graph it, I want to know what direction in that interval the graph of the tangent is going to look like. All right, but now I'm missing 3 more little intervals. So from pi over 2 to pi, we have that sine is positive, cosine is negative, so that means that the tangent is negative. Now you're wondering, Mr. O, how are you getting these values? We just got to work on them through our unit circle. Remember, everything is given there in the unit circle. You can go about it there, or you can just plug it in the calculator and figure that out. Okay, now from pi to 3 pi over 2, right, we have that sine is positive, cosine is negative, tan is positive, and then we have from 3 pi over 2 to 2 pi, 3 pi over 2 to 2 pi, we have that sine is negative, cosine is positive, tangent is negative. Now, you're probably wondering, well, Mr. O, well, how's this going to help me at all? Okay, what does this do? So, like I said, this is for the graph. Alright, so if I look at this, I'm going to make one big graph right here. Okay, so there it is. Now I have to do my intervals, right? So we said we're going to start off with negative pi, so I'm going to start, so negative pi over 2, and this is negative pi, and then I have pi over 2, then I'm going to have pi, then I have 3 pi over 2, and then I'm going to have 2 pi. Alright, so the first things I'm going to put in this graph, okay, are my asymptotes. So if I look back, I said that my vertical asymptotes is where my cosine is equal to 0. So in this, cosine is equal to 0 at negative pi over 2, pi over 2, and 3 pi over 2. So this is how you're going to graph them. I'm going to do it in a different color. So I'm going to have it pi over 2 right here, right? Just straight down. That's where my asymptote is. I have pi over 2 and 3 pi over 2. Alright? Now, the next thing I'm going to point out is plug in your zeros. Okay, so there's going to be a 0. That means that your x-axis at every pi, right? We had at negative pi to 2 pi. So as negative pi, you're going to have one here. I'm going to do this in blue, right? Because that's what I said here at the beginning, right? It would be a 0 right here, 0, pi, 2 pi, 3 pi, and so on and so forth. So at pi, negative pi, at 0, at pi, and at 2 pi. Okay, now we have the dots there. Now I have to do is follow this, the little chart that I gave you. From negative pi to pi over 2, we said that tangent is positive. Okay, so from this place, from here to here, right, it's going to be positive. So it's going to look like this, but it's never going to touch. So it's just going to keep on going like that. Alright, now my next one, right, it says from negative pi over 2 to 0, the tangent is going to be negative. So if it's negative, it's going to go like this. And then the next one, it says 0 to 2 pi over 2 is going to be positive. The tangent is positive, so it's going to go from here to here. And then from pi over 2 to pi, the tangent is negative. So that means it's going to go down, so it looks like this. And from pi to 3 pi over 2, as you guys can imagine or notice, is going to go to positive. And lastly, from 3 pi over 2 to 2 pi, the tangent is going to be negative. So it's going to look like this. Alright, and it's going to keep on repeating like that. So this is how a tangent function looks like. This is just your tan of x. Alright, so this is the simple part today. This is just to show you how I'm going to show you the transformations tomorrow. Alright, boys, if you have any questions, please don't hesitate to email me. I hope you all have a great day.